Why do more people like it? Why do more people want it? Why do more people buy it than any other TV? Well, the tubes are connected to the chassis is connected to the picture tube, the picture tube's connected to the tuning dial, the tuning dial's connected to the cabinet, and the name goes on right here. That name's dependable, you know, that name's reliable, you know, that name means quality in every TV set.
Yes, year after year, RCA Victor quality has been steadily improved by the experience and know-how that come with building more than 10 million sets. Starting here in the Cherry Hill Laboratories near Camden, New Jersey, RCA Victor continues to raise quality standards for the television industry. Here are some of the reasons why. With RCA Victor, quality is more than a philosophy, a way of thinking. It's a way of working, and it begins on a research and design drawing board. At RCA Victor Research and Development Laboratories, research engineers and advanced designers work together in the pursuit of quality. Electronic engineers continually probe into the future. Their only guideposts are ideas as to where sound and picture reproduction may be improved. These are the men who unlock the secrets of improved performance or find practical answers for improving quality. As these men work, one of their first steps is to build prototypes. Before being used, a new component is taken to the component's development and test laboratories. Here it receives exhaustive tests by RCA Victor's own staff of testing engineers before it is put into production. Transformers, for instance, are passed only if their insulation will withstand 5 times the voltage they will carry in normal operation. An average capacitor must be able to withstand at least twice its rated voltage and is also tested to measure stability under various temperature changes. All switches, relays, and bearings are mechanically tested to make sure that they are able to withstand the equivalent of up to 10 years' wear. Before manufacturing, prototype coils are handmade and then subjected to exhaustive tests. Some components are even tested under steam pressure to simulate extreme heat and humidity, and then electrically retested. Only after proving conclusively that they can function effectively under conditions far worse than those they will be subjected to in the average home are electrical components okayed for production. While basic electrical components are being designed and tested, tuners are being developed and improved upon in a special laboratory. Much of this highly specialized work takes place inside individual cages designed to screen out electrical interference. The operating characteristics of prototype tuners are carefully studied to make certain that they meet the high standards established by RCA Victor. Simultaneously, the Product Development Division searches for designs that reflect tastes and trends from all over the world. Hand in hand with styling design is the selection of quality materials to assure lasting beauty. Wood samples from all over the world are carefully considered. Hardware and fittings are selected carefully to complement the basic design. Colors and finish types are selected from a wide range of samples. Again, all these materials undergo initial testing to make sure they are able to withstand normal wear and still retain their beauty. Samples are put into freezing chests for a period of a half hour or more, then immediately put into a heat oven for a similar period, after which they are closely inspected for any tendency to shrink, warp, or swell. Paints and plastics are examined under ultraviolet lights to check their characteristics and make sure that they will retain full color and luster. When all components have passed quality tests, the go-ahead is given to build a prototype cabinet. In RCA Victor's own cabinet shop, skilled cabinet makers now help to bring to reality a handmade prototype. Finally, after the test finish is applied and is hand rubbed, the completed cabinet is ready to be tested as a unit. And even though each part has been individually quality tested, they are again tested to make sure that they do not lose any of their quality characteristics when assembled with other components. In the mechanical laboratory, the chassis prototype is assembled with all of its component parts. Once the chassis is assembled, it is sent into an electrical laboratory where engineers make elaborate tests to check out all its circuitry, aided by test pictures and patterns, originating from this room in the Cherry Hill laboratories. It operates much the same as any television station. However, by using a closed circuit, engineers can simulate conditions such as distance. They can also create their own interference so that they can be sure that a quality picture will be produced even under adverse conditions. When prototype cabinets and chassis have been checked individually, they are assembled as a unit. Then they are placed in a special echo-proofed chamber to study sound characteristics. Sound systems and speakers are thoroughly tested. A moving microphone picks up the sound at varying angles. The sound is measured by sensitive instruments to scientifically assure that each sound system comes up to RCA Victor's high standards. RCA Victor insists that every set produced meets or exceeds underwriters' laboratory listing requirements. This assures high safety standards against fire or electrical hazards. In Medford, New Jersey, RCA has established, at a cost of almost $150,000, a special field testing laboratory to carefully test all RCA Victor receivers to see that they comply with FCC requirements. It has long been known that an instrument, such as a television receiver, could, if not properly shielded, produce picture interference in other nearby sets due to signals being fed back into the air by the receiver. Engineering models and prototypes of sets are brought to this laboratory and checked to guide RCA Victor engineers in developing circuits that keep such interferences well within the required limits. Special equipment is used that can measure signal field strength in terms of millionths of volts. RCA engineers not only develop the techniques and standards used in these tests and measurements, they actually use them to develop sets with built-in quality long before FCC requirements were enacted as a law. When components have passed all tests, specifications are released to RCA Victor manufacturing plants and selected suppliers who have shown they can meet RCA Victor's rigid quality standards. Manufacturing plants submit samples of work before authorized to produce on a quantity basis. This sample is subjected to the same exhaustive testing as the prototype to make certain that none of the original quality is lost in the manufacturing process. The same exacting quality standards are applied to RCA tube manufacturing and design. 4 million tubes are made each month at RCA's Harrison, New Jersey tube plant alone. Yet every tube is carefully checked. This machine makes 19 different tests on each tube. It automatically rejects any that do not pass. At each stage of tube manufacturing, samples are taken for even closer analysis and testing to make doubly sure quality standards are maintained. In Harrison, all incoming basic materials are sample tested. The control of purity of the materials used in making tubes is a vital necessity if contamination and breakdown are to be eliminated. Another example of the philosophy, to produce the best, you must begin with the best. In this work at Harrison, research engineers work with the unusual. Machines that clean materials with ultrasonic sound waves. Machines capable of testing the strength of wire finer than a human hair. Even liquid nitrogen, as well as induction furnaces capable of heats of over 4,000 degrees Fahrenheit. To maintain accuracy, a special laboratory checks all test equipment using units certified by the National Bureau of Standards. Here, quality standards are also controlled by checking characteristics of tube samples against master specifications. After manufacturing, every tube is aged in racks at 3 to 4 times rated filament voltages, and then 100% tested for operating characteristics. When packed, each lot is coded to identify them in event sampling checks reveal deficiencies. In Harrison's life testing laboratory, 250,000 sample tubes can be given rigorous life and performance tests each year. 15,000 to 25,000 tube samples can be tested here at one time. Some up to 5,000 hours, 10,000 hours, or as much as 25,000 hours. 2 hours on, 10 minutes off. Day and night, samples are turned off and on to duplicate years of actual operation. Still further testing is done at the RCA Woodbridge plant in New Jersey, where warehouse samples are checked in use in all types of operating television sets. In Lancaster, Pennsylvania, color kinescopes are produced with the same cautious guarding of quality. Typical of Lancaster's painstaking controls is the incoming inspection of kinescope glass faceplates and funnels. In a series of 54 checks, critical dimensions are measured within thousandths of an inch to make certain that when assembled with electrical components, each tube can deliver the peak picture performance built into the design. This electric pneumatic contour gauge checks the inner surface of faceplates to make certain they are sections of a sphere. In one simultaneous operation, it can check 15 gauging points. The shadow mask is subjected to even more exacting inspections. Etched with over 250,000 holes, it shadows the phosphor dots, yet is transparent to the correct electron beams. This plant is completely air-conditioned and filtered to keep dust from getting into any components, such as this 3-gun assembly, and affecting operation once sealed in the tubes. Before being applied to the tube face, each phosphor color is mixed in its own room, where color and brightness can be matched down to a wavelength. The resulting mixture is then photosensitized and taken to the screen room. Application of the color phosphor dots is a precision operation requiring microscopic inspection. Here, each faceplate is married to a shadow mask and placed over a housing which uses mercury arc lamps to duplicate electron gun beams. Every completed tube receives a 100% performance inspection, followed by the life testing of representative samples. These checks reveal consistently a life expectancy equal to that of black and white kinescopes. Prior to shipment, quality checks are made after a 3-day waiting period in shipping pack. All 3 guns are tested electrically, and an entire lot retested if deficiencies are revealed. In cabinet plants, such as Monticello, craftsmanship and precision are also important aspects of quality production. Workmen in these plants are skilled craftsmen who come from families where woodworking is a tradition. Starting with selected raw materials, such as mahogany planks, these craftsmen proceed to transform them step by step into the cabinet designs for which RCA Victor has become famous. Cabinet parts are carefully matched so that the color and grain of the wood will be complementary. The machine used here is capable of making 15 different cuts simultaneously and is accurate to within 1/64th of an inch. 2 cabinet legs are carved here at the same time and then cut apart. Some cabinets receive as many as 12 finishing operations. Each receives multiple coats of lacquer to produce depth of finish, seal in the quality, and protect the rich beauty produced by quality craftsmanship. Each cabinet is given a final inspection. It must meet RCA Victor's quality standards before being released for shipment to one of RCA Victor's instrument manufacturing plants. Cabinets are then shipped to the Bloomington, Indiana, or the Indianapolis plant. But before cabinets or any other incoming part or component go on the manufacturing line, samples of the shipment are taken to a parts testing center within the plant itself. Here, exhaustive tests double-check the quality of parts to be used in the production of sets. If, for any reason, parts fail to meet engineering specifications, they are rejected together with the complete shipment and returned to the manufacturer. Mechanical parts are sample tested for dimensional accuracy. Such things as thicknesses, hole placements, and diameters must be exact. To get such accurate measurement checks, this table of solid granite, weighing over 2 tons, is used as a base. Its flat, polished surface is accurate to within 1/1000th of an inch. Parts with dimensions too small to check with the naked eye are placed in testing equipment which magnifies them as much as 50 times. This permits the accurate measurement of the most minute cuts where tolerances must be exact. Every shipment is sample tested from the smallest part to the largest. Only after this quality check do skilled workers, together with millions of dollars of precision machines, begin the task of accurately assembling the 1,001 parts that result in a finished product, accepted as the recognized leader in its field. Skilled workers share the responsibility that comes with the pride of building the television set found in more homes than any other, each adding a priceless touch that comes only from years of experience. This craftsmanship is ensured in each of the manufacturing plants by quality engineers whose sole job is to make sure that quality is maintained in the assembly of component parts. The aim of these men is to discover troubles before they can get into the field. These are the men who plan the strategy and solve any quality control problems that may arise. At each stage of assembly, inspectors judge with a trained eye the work of men, yes, and the work of machines. For example, printed circuit boards are soldered instantly in a single operation. This type of design and soldering assures the same reliable electrical performance as demanded and used in such exacting equipment as computing machines and guided missiles. Even this mechanical operation is checked. Over 17 million printed circuit boards have already been produced for RCA Victor consumer products alone. Amazing testimony to the effectiveness of printed circuit boards is the fact that less than 0.2% has been required for spare parts replacement stock. Every soldered joint on each printed circuit board is checked by a trained eye. It must have just the right amount of solder, not too much, not too little, but just enough. Here is the heart of a television set, the tuner. Each circuit in the tuner is aligned individually by a skilled technician to assure peak operating performance. All components and sub-assemblies that reach this point have passed all checks, tests, and inspections. Many wire connections are made quickly and effectively by use of special wire wrapping guns. This is a new technique developed by the communications industry for making electrical connections where extreme dependability is required. It's cleaner, faster, and neater than soldering. And all along the line, there are inspectors watching, probing, searching in the endless effort to maintain RCA Victor's high-quality standards of manufacturing. All chassis receive a 100% inspection and performance check. To make certain that all sets can be aligned exactly and tested under actual operating conditions, this master signal center contains approximately 5 times the amount of transmitting equipment found in the average commercial television station. It can generate test patterns and signals of over 100 different frequencies. It sends out these test patterns and pictures in color and black and white to control points throughout the plant. As each chassis passes its performance test, it moves on to final assembly to be joined with cabinet and kinescope. Samples of finished sets are selected for the life testing laboratory, where they are tested from 50 to 2,000 hours. The sets are continually turned on and off. On for 105 minutes, off for 15 minutes, to subject them to alternate heating and cooling off. Throughout the tests, technicians using sensitive testing equipment keep a close clinical report on the action of each set. Other sets coming into the life test laboratory are given some mighty rugged testing. After tests such as these, the sets are taken out and given performance tests. Of course, all cartons are designed to protect their quality cargo from the rigors of rough handling. In addition to all of the quality tests and inspections maintained in the course of manufacture, a finished goods testing operation of extensive proportions is conducted at the factory, covering instruments selected at random from warehouse stocks. In 1 year alone, between 30 and 35,000 instruments are checked. Some sets are sent on local road tests. Still others are shipped to Cherry Hill, New Jersey for examination in a laboratory unique in the industry. The Consumer Acceptance Laboratory, where the instruments are inspected completely from the consumer's point of view. A report is made on each set. If a fault is uncovered, which proves to be in several sets from the same lot, typical of a representative lot, the manufacturing plant is notified immediately, and manufacturing and shipping are halted until the fault is corrected. Consumer's Laboratory sends a continuous stream of findings to manufacturing, engineering, and management. In addition, every day, a quality pulse beat is received from people all over the United States who have recently purchased an RCA Victor television set. These owner report forms are attached to each set and invite every purchaser to comment on the quality and performance of the set they have just bought. Every customer reply form is personally acknowledged, the information tabulated and analyzed for ways of further improving consumer acceptance. When immediate action is indicated, the RCA service company is contacted and proper action taken. Approximately 45 service branches spread throughout the country work closely with service installation men. These men, in turn, make reports on the performance and condition of every RCA Victor set they install. All forms and reports are tabulated and searched for any information that will help to increase the quality, performance, and value, or eliminate trouble spots. This information is sent back to the men who design, test, and build the sets. Quality-conscious men who pursue and crystallize elusive and advanced ideas that will lead to greater quality, who demand that component parts come up to the highest quality standards, men who are prepared to cut deep beneath the surface in their pursuit of quality as RCA Victor continues to produce television sets that have quality built right into them, from the design board to finished production. In this film, we have seen some of the reasons why, but these are only a few. There's one other big reason for the success of RCA Victor Television that we can't forget or overemphasize, and that is the cooperation and efforts of men like you who are sitting here today. Men who are looked upon as key members of the RCA Victor family. Men who are as close to RCA Victor as anyone who contributes to this great team. No matter how well a set is made, no matter how carefully quality is built in and protected all the way, it still remains for you men who are on the firing line to add the final touch of success. Namely, bringing fine products to a successful sales climax. And that is why RCA Victor always looks upon you as important members of the RCA Victor family. Looks upon you as very necessary partners in quality.
The signature every century has been its skyline. The very ancient, the old, the medieval, the modern. Imprints of man's never-ending path of progress, silhouetted against the ageless canvas of the sky. Our day, our times, our signature, our skyline. Metal fingers beckoning to the invisible, calling to sound the ear cannot hear, and sight beyond the range of the unaided eye. Our era, the era of television. The dream of television had persisted for centuries. The human eye is a miraculous instrument, perceptive, sensitive, forever tuned to the pulsating wavelengths of light. Yet the eye is hemmed in by horizons. It cannot see over a hillside or beyond the haze of distance. To extend the range of human eyesight, man developed marvelously sensitive instruments, binoculars. Giant telescopes to probe the furthest span of space. But always there were barriers, distance. Could man fling pictures to the sky and gather them in at a distant point? It was a provoking challenge. And nowhere did the challenge provoke more unending experiment and research than at RCA. As far back as the 1920s, two men took up this challenge. They shared the irresistible dream of television. David Sarnoff, chairman of the board of RCA. Dr. Vladimir Zworykin, honorary vice president and technical consultant of RCA.
Dr. Zworykin, every now and then I like to put the calendar back and remember another important occasion when you came to my office. You were a good salesman, and I was a good dreamer. We talked about broadcasting moving images by electronics. And I remember that I asked you what it would cost to develop an all-electronic television system. Do you recall your estimate?
Of course I remember. I asked something like $100,000.
Your estimate missed by quite a bit. It cost RCA more than $50 million to create, develop, and introduce America's first all-electronic television system. And since that time, as you know, RCA has spent another $70 million to pioneer and develop the compatible color television system. But how well that money was spent. We succeeded in extending human sight far beyond the horizon.
Yes. This is wonderful thing about television. The extension of our sight. You are better acquainted with this progress, General, than anyone because of your participation and leadership in so many phases of television development. It was nearly 30 years ago when I came to your office with that tube, the first eye of television.
Yes, I well remember it. Nearly 30 years ago. And what a great invention this tube has become. It certainly has fulfilled its destiny.
Well, General, this is the grandfather of the pickup tube. Do you want to see the newest grandchild?
Well, I'm all for grandchildren. Let's have a look at it.
Well, here it is.
Well, this certainly looks very interesting. What do you expect this grandchild to do?
Well, that's what we call miniature Vidicon. And I hope eventually it will replace all the existing pickup tubes for all the purposes.
Well, that's very interesting and certainly very promising because what we need to do is to reduce the size and the cost of these components so that television, color television, both at the transmitting and the receiving end, may be within the reach of everyone. That is my hope.
The turning point came in 1923 when Dr. Zworykin invented the iconoscope. This tube, after years of further development, became the image orthicon, the electronic eye of the modern television camera. In 1929, Dr. Zworykin and his associates announced the first successful electronic kinescope, forerunner of today's television picture tube. The circuit was complete. All electronic television was achieved. It worked. How? The lens of the television camera acts like the iris of the human eye. It gathers in the light rays and focuses them on a mosaic of light-sensitive material that is built into the picture tube. The light-sensitive material converts the light into electrical impulses, a reaction varying with the strength of the light. The optic nerve of the camera picture tube is the electron beam, controlled by electromagnets. The beam scans the picture, which is on the plate, in rapid sweeping motions from side to side, from top to bottom. When the beam hits the image, it loses varying amounts of electrons and then bounces back to the opposite end of the picture tube, where it is amplified millions of times. It is led off to the transmitter in the form of electric current. The signals are broadcast as radio impulses into space. Heart of the receiving set is the kinescope. Here, the action is reversed. The stream of electrons, synchronized perfectly with those of the camera tube, literally picture information on a chemically treated screen line by line. The glow is bright when the beam is strong, less bright when it is weak. Thus, the picture is reassembled. 1931. Atop the Empire State Building, the National Broadcasting Company, a service of RCA, erected the transmitting antenna for experimental television station W2XBS. Now, RCA's technicians and scientists tackled the next goal, improvement of picture quality. Hitherto, using a mechanical process, the best that could be transmitted was a crude signal of 60 scanning lines. RCA turned to the new science of electronics, discarded the mechanical spinning disc, and soon doubled, tripled, then tripled again the scanning lines. Now television was really on its way. In 1937, television strode out of the studio with mobile vans developed by RCA and NBC, versatile, self-sustaining. New eyes, new vision for the world. A man could sit at home, yet his eyes could scan the countryside. A bright new era dawning, a new dimension in communications. Distance reduced to microwaves, walls, barriers, mountains erased. Television, the ultimate triumph in man's search for sight beyond the range of the human eye. 1939, television is ready to make its official public debut. The setting could hardly be more perfect. The New York World's Fair. Its theme, the world of tomorrow. And the world of tomorrow became the world of today. The RCA exhibit building, where on April 29, 1939, David Sarnoff stated, "We have added radio sight to sound." NBC cameras probed, explored, scrutinized. Viewers watching the 3,000 television sets then in New York saw the first president ever televised, Franklin D. Roosevelt, officially opening the world of tomorrow. Via television, the viewers toured with the King and Queen of England through Pavilion and Midway. Day by day, television produced new adventures, new vistas, new excitement, new thrills. NBC presented the first baseball game ever televised, August 1939. 1940, the nerve-tingling drama of a national political convention, the first ever televised. Philadelphia and New York were knit together by the electronic miracle of television. Radio relays, pioneered by RCA, and the telephone company coaxial cables wiped out the horizon as the far limit of telecasting. Still in the trial and error stage, television began studying its own future as a tremendous new medium of entertainment. The first programs were simple, unpretentious, proving grounds for technicians, cameramen, directors, writers, and performers. Slowly, the know-how was gained. Bit by bit, creative imagination began to give form and substance to the new art form called television. (1941), a fateful year, war, and the beginning of a 4-year blackout for commercial TV. And television enlisted for the duration. Research went forward at war tempo. At RCA's David Sarnoff Research Center, Princeton, New Jersey, 24-hour shifts explored every corner of the new world of electronics. RCA electronic scientists and engineers made important contributions to the development of radar, sonar for submarine detection, the sniper scope that made it possible to see a target in darkness. Thus, the progress of perhaps a peacetime decade was compressed into 4 short years. 1945, the war over. After 4 years of unparalleled war effort, denial, sacrifice, the American public hungry for the rewards of peace. And television, with its promise of endless hours of enjoyment, entertainment, was part of the peacetime dream. RCA, although by far the leading producer of television sets and television tubes, realized that the future health of the industry required the vital bloodline of competition. So, in a move without precedent in American industrial history, it opened its blueprints to licensed competitors. This was the shot in the arm the industry needed. Television came of age. In the NBC studios, the cameramen, lighting experts, set designers, writers, directors were experiencing, studying, learning the new techniques of a great new medium. Programming was better, more varied, more entertaining. (1949), an historic television first, a presidential inauguration. As Harry Truman took the oath, the event was carried over the 16-city NBC television network, extending from Washington north to Boston and west to St. Louis. Television was moving with giant strides, and in less than half a dozen years, a flip of a switch in master control could send the television image coast to coast. A dynamic industry employing more than 1 million. Television, an unparalleled blending of science and art, invention and engineering, private incentive and public service. By television, American business has found a most effective advertising medium, and in turn, advertising has provided the resources that sustain the standards of programming and permit the never-ending research that is the heart of the television industry. Television servicing alone has become a major industry, employing nearly 100,000 people. Yes, in little more than a wink of time, television has entered our homes, our lives, imprinted new silhouettes on our skyline. And all this has been just the beginning. There was still another dream to be realized, still another dimension to be added. Black and white television had been the herald. It put millions of TV sets into our homes, built hundreds of TV stations, created an industry, an art, a public service, an exhilarating component of our American way of life. It provided the foundation for the next giant step forward. Color. This is a world of color, and the men of television long dreamed of capturing the full paint pot of nature and brushing it on the screen. How could it be done? It was not an easy triumph, as General Sarnoff recalls.
When we first began to think of television in the early 20s, we would have been content if only the rose could have been televised in black and white. That miracle had no sooner been achieved when the eye, sensitive to color, observed that the rose in monochrome lacked its true beauty, and the cry went up for color. Never had scientists been put under such pressure and demand. It has been my privilege and a fascinating experience to watch the scientists at work on color television. I marvel at their accomplishment in bringing into focus the principles of radio, optics, electronics, photography, chemistry, and many other essentials so that they might all work together to make color television practical. I congratulate the RCA scientists, researchmen, and engineers who pioneered and developed this new science and art, and then created the compatible color television system and the famed color picture tube.
Color. Color, the touchstone of reality, the vivid, pulsating miracle that gives substance to shadows. Beauty, grace, and enchantment to a picture. Problem: how to harness a stream of electrons for color. Early, General Sarnoff had set forth the fundamental goals for color television. First, it must be all electronic. Second, it must be completely compatible. These were the goals. The road was long, difficult, but it led to one of the historic inventions of our times, the RCA tricolor television tube, the tube with the heart of a rainbow. The lens of the color television camera collects light rays in full color from the scene being televised. Within the camera, an ingenious system of mirrors breaks down the light rays into television's three primary colors: blue, green, and red. They are focused through the lens system to the special camera tubes provided for each primary color, and the primary color signals thus produced are simultaneously processed for transmission. By the miracle of compatibility, color programs can be seen on standard black and white sets without any change or adjustment. Color receivers, which can also pick up standard black and white broadcasts, decode the color information and apply the picture in all its vivid beauty to the tricolor tube. The world of color. Color captivates attention and brings the beauty of creation close to home. Color transforms the commonplace into the beautiful. It makes the humdrum memorable, gives new power to advertising and merchandising. Color, the fabric of the rainbow riding piggyback on an invisible stream of electrons. The Tournament of Roses in Pasadena, California. Telecast in color by 21 stations of the NBC network in the first west to east transmission in color on New Year's Day, 1954. All the glory, all the reality of nature. With the added dimension of color, television programming probed new horizons. Once again, technicians and artists accepted the challenge. In an incredibly short time, they had devised the techniques to integrate color into television programming. An old word took on new color, new meaning. Spectacular, an adjective made over into a noun. Spectacular, the finest in television programming. Into the home came the greatest in drama, such as The Four Poster, starring Hume Cronin and Jessica Tandy. The list of spectaculars continues to grow to imposing proportions. An entirely new adventure and entertainment for the American public. For pioneered and developed by RCA, is counted as one of the outstanding scientific and artistic triumphs of the 20th century. It has added a new dimension to the entertainment arts and has intensified television as a social and educational force. Mobile units in a coat of many colors transmit outdoor color telecasts, adding new sparkle and new buoyancy to television coverage of great sporting events. The first World Series ever color televised, 1955. Another color television first, the Davis Cup matches, 1955. Football, the youngest art form, the easiest understood, the liveliest, the brightest. Television, full and captivating color. For I dipped into the future, far as human eye can see, saw the visions of the future and all the wonders that would be. One day through television, the entire world will stream into our living rooms with the velocity of light. Not too far beyond the horizons, international television, to span oceans, capture all the vivid beauty of far lands, bind people of all nations tight together by better understanding, better knowledge, through instantaneous communication of sight and sound. Motion, color, vibrancy, people. In the twinkling of an eye, it is caught by the lens of the color television camera, transmitted by invisible waves to all points of the compass. Atop a million homes, antennas pluck the pictures from the sky, and a flick of a switch or the turn of a dial, the scene reappears on the television screen. To perform this split-second magic with true fidelity of color, of sound, of reality, this is the wonder of color television. Compatible color television, an historic example of RCA's continuing efforts to open new horizons of electronics for living. Electronic, easier and safer.
Dr. Orestes Caldwell, editor of Electronic Industries and former member of the Federal Communications Commission.
I'm glad to have this opportunity to speak to you men and women in the service of America. I believe in this world to come. I think it's going to be a pretty good world. But I've been asked to tell you about television, so I'll trim the philosophizing. Television is most certainly here to stay. It's going to brighten the world of your home. But more important to many of you, it's going to create a lot of new jobs. Now, none of us like crystal gazing, so let's take a look at what is actually happening now. 9 experimental telecasting studios are already operating, with pre-war equipment and skeleton staffs. While the electronic industry is busy finishing its war job, a handful of people, girls, ex-vets, older men, are keeping the television field alive, experimenting, ironing out kinks, but proving that television will definitely be part of American life when the go-ahead comes. Sight teamed up with sound to bring the world to your easy chair. telecasting studios will be a combination of Broadway and Hollywood, and you'll get the best of both for the price of your television set and a few cents worth of electricity. And outside the studios, mobile televising units, portable stations on wheels, are now experimenting with remote pickups, getting primed to bring you on-the-spot news and history in the making. When television networks are formed, you will have a direct wire to every place a television camera can be set up. A world of sports at your fingertips.
They're off. That's interpreter number 2 right in front. And the field races past the stand with interpreter on top, low man in second place moving up on the outside.
Mayor LaGuardia pitches the first ball. Red Ruffing is taking his time, and it's a hit.
There's a capacity crowd here at Madison Square Garden tonight to witness the semifinals of the Golden Glove.
Telecasting is done on a limited schedule now, but tomorrow you will have a permanent ringside seat everywhere from Madison Square Garden to the House of Congress. You'll see transmitted by television, newsreels, and Super Hollywood productions. Plays and musicals, command performances in your own living room. These men at Halloran General Hospital, where there are 100 sets, can tell you television is here to stay. Even now, without the technical improvements that will come after the war, the television picture has the quality of a good home movie. The pre-war models in use today have a small screen, but here's a practical working model with a 16 by 22-inch screen that goes into production just about the time you're being measured for civvies.
This is NBC, the National Broadcasting Company. WNBT, New York.
Well, that gives you a pretty general idea of what's happening. Now let's see how television works. You're going to find a new type of aerial against the skyline of America when you return. It will be up high because television waves, like light rays, don't bend and are stopped by the horizon. So the higher the aerial, the farther the waves travel. But first, what is a television wave? As you know, all objects reflect light, some more, some less, depending on their color. The white jacket of these fencers is reflecting more light than their dark trousers. The television camera lens, like an ordinary camera, picks up these differences in light and shadow. Only instead of film behind the lens, we have the iconoscope, familiarly known as Ike. The camera plate of the iconoscope is made up of millions of sensitive electric eyes. These eyes pick up electric impulses from the object being televised and form a picture which is then transmitted as separate electric impulses from the camera plate to the receiver screen. There the impulses are converted back to pinpoints of light and shadow to reform the picture on the screen. Here the process is slowed down for you. Actually, the impulses travel from the camera to the receiving set at the rate of 4 million impulses a second, forming the picture in motion. Fantastic. But our children will grow up with this miracle enriching their lives and giving them a new understanding of the whole world.
Gosh.
By harnessing electrons and vacuum tubes, our research scientists, backed by American industry and manufacturing skill, have developed this new means of communication to the point where it promises to become a post-war billion-dollar industry which can serve our nation and the world in new and wonderful ways. Let's listen to a man who knows. He is one of the great leaders in the world of electronics, Brigadier General Sarnoff, President of the Radio Corporation of America.
When the First World War ended, it was my good fortune and privilege to play a part in the launching and subsequent development of a new industry called broadcasting. There were some who said it had great promise. There were others who said that it was a noisy, sputtering gadget, a passing fancy. The rest, you know. Now let us see what possibilities exist for television once the war ends.
Here are the possibilities. In the manufacturing field, 60,000 men and women will be needed to make the first sets, which will retail for about $200, with 18 million Americans ready to buy them. Help wanted. Electronic experts, assemblers, wiremen, machinists, finishers, testing personnel, sheet metal workers, drill press operators, spot welders. Television is just made to order for GIs with radio and radar experience. 85,000 maintenance men are going to be needed to install and service the 30 million sets expected to be sold within the first 10 years of full-scale production. And in the distribution end of the business, 135,000 jobs are going to open up in the new shops and sales organizations that will supply the huge consumer demand. All in all, 300,000 well-paying jobs are expected to be created by television within 5 years after the new industry really gets rolling. Well, that's a comprehensive view of the industrial picture. Now what about television production? Here's a man who qualifies as an expert on that subject. Meet Mr. Gilbert Seldes, head of production of the Columbia Broadcasting System.
They tell me that a great many of you may be interested in jobs in television production. Well, I think you're entitled to the hard, solid facts in the case. As of spring 1945, we are employing 62 people. They work a full week to put on 4 hours of programs on the air. That doesn't mean 4 hours a day, it means 4 hours a week. If we were on the air 8 hours a day, 7 days a week, we'd need at least 7 times as many people, in the neighborhood of 500. And we're only one studio. There are 900 radio broadcasting stations in the United States today. And it's anybody's guess how many television stations are going to spring up. We can just be sure that the faster we deliver good entertainment and good pictures, the more jobs we're going to create. And there will be a lot of jobs. You compare television with radio, for instance. Here is a radio newscaster on the air. One man in the studio, one in the control room. And here is a television newscast. And a lot of work went into it before it got this far. Now as for the movies. Here is just a medium colossal production underway. Yes, it takes a lot of people and many months to make one. Yet commercial television will probably use more material in 1 week than all the studios in Hollywood turn out in a year. And finally, in the theater, you produce a show, it may run for years. In television, every night is opening night and closing night too. Now let's look at some specific television jobs. Some of them you'll see come from radio, movies, and the theater. Some are new. Here are 2 men doing a job never heard of before. They are riding the Ike. Shaders and switchers in the control room see that the pictures come out right. At the transmitter, they see that they get out on the air. And electronic experts keep it all functioning. You men with radio and radar training are only a hop, skip, and jump from the industry's needs. Then there will be modifications of established professions. Writers, directors, producers, scenic designers, and just to show you wax, waves, and spars that this isn't exclusively a man's world, there'll be costume designing and stage management. Then behind the scenes, makeup, props, electricians, and almost everything else from carpenters to model makers. But the great thing to remember is that we've just begun to discover the possibilities of television. And these are only a few of the jobs that already exist. Many more are bound to develop as we go on.
That's it. Television. And some interesting jobs which some of you may be qualified for. But more than that, television can be the window to the whole world, a medium through which the United Nations can better understand each other and live together in the world of tomorrow.
Crowds, music, color, excitement. Who doesn't enjoy a football game? If you're one of the lucky ones able to get a ticket. But of course, if you're not, well, it's just too bad. Unless you happen to live in some parts of the country where, thanks to the newest marvel of modern science, television, you can just lean back in a comfortable chair in the theater or in your own favorite chair at home, relax and watch the game. Out at the stadium, the television cameramen are seeing to it that you can follow every detail of the game. They're out there on the sidelines following every important piece of action. Cables connect the cameras with the mobile units, which are parked outside the stadium. And from these trucks, the scenes covered by the cameras are relayed to the main television transmitter. Now, let's see what a television studio looks like. It's a mighty busy place when a broadcast is being made from the studio. Great banks of light swivel down to flood the scene. Cameramen wheel in and out to pick up the action from the angle selected by the director. To keep the action continuous while costumes are changed, and while different sets are made ready, and action shown which could not take place on a small stage, portions of some broadcasts are made by projecting prepared motion picture film right into a television camera. Using the same actors and identical sets, the motion pictures are made in advance. The electrician, the cameramen, the studio manager, and the actors are all controlled by the director. His job is to see that the broadcast proceeds smoothly and without breaks, because the picture on the television screen must be continuous.
Camera 1, move in close on the girl.
Television and motion pictures are alike, because in both, a series of still pictures is flashed rapidly before our eyes, so rapidly that the memory of each picture lingers long enough so that it blends with the next picture, and the objects in the pictures appear to move. And now let's see what makes a picture a picture. Look closely at this one. Closer still. Let's use a magnifying glass. Here we see that the picture is really made up of thousands of tiny dots arranged very close together. But normally, our eyes don't notice the dots, especially when the picture is being moved. This fact helps to make television and motion pictures possible. Television is simply a way of sending these dots from a transmitting station and putting them together to make a picture on the screen of a receiving set. Here's the way it works. Inside the television camera is a magic electric eye called the iconoscope, one of the most important parts of which is this sensitive plate called a mosaic. It is a rectangular piece of mica covered with millions of tiny photoelectric cells, arranged something like this. The scenes being televised go through the camera lens and fall on the photoelectric cells. Some of the cells receive lots of light, others very little. Each cell, according to how much light it gets, builds up a corresponding electrical charge. These charges collectively make up an electrical image on the mosaic. These cells with their electrical charges are scanned by a stream of electrons. The scanning beam skips every other line and returns to scan the remainder of the picture, completing 30 pictures a second. Each picture is composed of 525 individual scanning lines. An electrical impulse is released each time this stream covers a group of the photoelectric cells. Each separate impulse travels from the sensitive plate of the iconoscope in sequence over wires to the transmitting station, where it is then sent out into space to be picked up by aerials connected to television receivers. Here, the electrical impulses are carried to another magic tube called the kinescope and are used to control another stream of electrons which bombard the face of the kinescope, which is really the viewing screen. When the beam strikes this fluorescent screen, each electrical impulse is changed back to a spot of light. In other words, each spot of light picked up by the mosaic of tiny photoelectric cells in the television camera creates a corresponding spot of light on the receiving screen. It moves back and forth so rapidly, actually more than 2.5 miles per second, that a complete still picture is formed, almost instantaneously. The quick succession of 30 pictures a second produces the apparent motion. That is why the pictures we see on the screen of our television receiver seem to move. Television has come of age. Here, for instance, is a reproduction of one of the first images received on a television screen. Compare that crude picture with these of today, and you can judge for yourself how far along the road to perfection television has traveled. It is bringing entertainment to thousands of people. Through its magic, we are able to enjoy a combination of the radio, motion pictures, and the stage right in the comfort of our own homes, simply by pushing a button and turning a dial. Of course, television can't perform such miracles as this, yet. But perhaps there's no harm wishing that it could.
Music, color, and excitement. Who doesn't enjoy a football game? That is, if you're one of the lucky ones who can get in. If you're not, well, it's just too bad. But wait a minute. There may be another answer. Yes, thanks to television, that marvel of modern science, even our unfortunate friend and millions of other people can sit back in the comfort of their own homes and enjoy every thrill of the game with no struggle for tickets. Out at the stadium, the television cameramen are seeing to it that you can follow every detail of the game. They're out there on the sidelines, following every important piece of action. Cables connect the cameras with the mobile units which are parked outside the stadium. And from these trucks, the scenes covered by the cameras are relayed to the main television transmitter. Now let's see what a television studio looks like. It's a mighty busy place when a broadcast is being made from the studio. Great banks of lights swivel down to flood the scene. Cameramen wheel in and out to pick up the action from the angles directed by the director. To keep the action continuous while the costumes are changed and while different sets are being readied, or to show an action which could not take place on a small stage, portions of some broadcasts are made by projecting prepared motion picture film right into a television camera. Using the same actors and identical sets, the motion pictures are made in advance. The electrician, the cameraman, the studio manager, and the actors are all controlled by the director.
His job is to see that the broadcast proceeds smoothly and without breaks, because the picture on the television screen must be continuous.
Camera 1, move in close on the girl.
Television and motion pictures are alike because in both a series of still pictures is flashed rapidly before your eyes, so rapidly that the memory of each picture lingers long enough so that it blends with the next picture and the object of the picture appears to move. And now let's see what makes a picture a picture. Look closely at this one. Closer still. Let's use a magnifying glass. Here we see that the picture is really made up of thousands of tiny dots arranged very close together. But normally our eyes don't notice the dots, especially when the picture is being moved. This fact helps to make television and motion pictures possible. Television is simply a way of sending these dots from a transmitting station and putting them together to make a picture on the screen of a receiving set. Here's the way it works. Inside the television camera is a magic electric eye called the iconoscope, one of the most important parts of which is this sensitive plate called a mosaic. It is a rectangular piece of mica covered with billions of tiny photoelectric cells arranged something like this. The scenes being televised go through the camera lens and fall on the photoelectric cells. Some of the cells receive lots of light, others very little. Each cell, according to how much light it gets, builds up a corresponding electrical charge. These charges collectively make up an electrical image on the mosaic. These cells with their electrical charges are scanned by a stream of electrons. The scanning beam skips every other line and returns to scan the remainder of the picture, completing 30 pictures a second. Each picture is composed of 525 individual scanning lines. An electrical impulse is released each time this stream covers a group of the photoelectric cells. Each separate impulse travels from the sensitive plate of the iconoscope in sequence over wires to the transmitting station, where it is then sent out into space to be picked up by aerials connected to television receivers. Here the electrical impulses are carried to another magic tube called the kinescope and are used to control another stream of electrons which bombard the face of the kinescope, which is really the viewing screen. When the beam strikes this fluorescent screen, each electrical impulse is changed back into a spot of light. In other words, each spot of light picked up by the mosaic of tiny photoelectric cells in the television camera creates a corresponding spot of light on the receiving screen. It moves back and forth so rapidly, actually more than 2.5 miles per second, that a complete still picture is formed almost immediately. The quick succession of 30 pictures a second produces the apparent motion. That is why the pictures we see on the screen of our television receiver seem to move. Television has come of age. Here, for instance, is a reproduction of one of the first images received on a television screen. Compare that crude picture with these of today, and you can judge for yourself how far along the road to perfection television has traveled. It is bringing entertainment to millions, and through its magic, we are able to enjoy a combination of radio, motion pictures, and the stage. Actually, some television patents were issued several years before the first automobile was built. But because of many technical difficulties that had to be overcome, its development was much slower. Just as the modern automobile is the result of years of research, scientific engineering, and testing by countless miles of actual use, television is the result of endless experiments and new discoveries by patient scientists toiling in their laboratories. It has been developed just as the easy riding qualities of today's automobiles were developed by progress through constant improvement. Today we sit back in roomy, comfortably cushioned seats in steel bodies, insulated against heat and cold and noise, surrounded by windows of crystal clear glass, controlling the ventilation to our needs, riding smoothly over all kinds of roads in luxury undreamed of a few short years ago. Of course, television isn't yet ready to perform miracles like this, but who knows what the future holds. It's fun guessing, though.